All right, this last example is a really important example because this is something that, as individuals you may have to face, and that's refinancing a loan. So one of the biggest loans that people typically will take out is a mortgage. So if you want to buy a house, you usually have to take out a mortgage because a house is so expensive and most of us don't have, $300,000 lying around to buy a house. So when you take out a mortgage, this is a very long-term loan, and so over time, you might be able to get a better interest rate, especially if you have, a 30-year mortgage. The market is going to change, and so you might be able to get a better interest rate 10 years down the line. So we want to look at an example where we have a mortgage, and then after a certain amount of time, the interest rate available will improve, and so we could do what's called refinancing the loan. And so when you refinance the loan, you basically take out another loan, and that pays off what you had remaining on your previous loan, but now you're going to be paying that new loan for a different length of time, and so you'll have different monthly payments, and you should end up saving in interest. So let's get started here. This is going to be sort of a multi-step problem here. First, Stephanie has a 30-year mortgage for $125,000 at 9.5% annual interest compounding monthly. What are her monthly payments on the loan? First of all, anytime you're talking about a loan, you're talking about an amortization. So we don't have to worry about using some different formula. This is an amortized loan. Let's see. We know a PR. I didn't want A. Here we go. PR, little r, little n, and T. So P is the present value of the loan, so that's how much she borrowed it for. That's $125,000. The periodic payments are unknown. Interest rate is 0.095. We are compounding monthly, so N is 12. And this loan is going to last for 30 years, and so T is 30. So we can go ahead and set up our formula, and we end up with 125,000 times 1 plus 0.095 over 12 raised to the 12 times 30, and this is going to equal R times 1 plus 0.095 all over 12 raised to the 12 times 30 minus 1, all divided by 0.095 over 12. And let's see, on the left-hand side, we end up with 21,36,857.725. And on the right-hand side, we have R times 20,33.035174. Dividing, we end up with $1,051.07 is our monthly payment. So right now, Stephanie will pay off her $125,000 loan by paying $1,051.07 every month for the next 30 years. Okay. Now remember, when you take out a loan like this, you're going to be paying back a lot in interest because this loan lasts for so long. So if this first payment that we're making, most of this is not going to the principal. If you look at $125,000, the first month, the amount of interest is going to be pretty close to $1,051.07. So you can go ahead and look at that. If you take $125,000 for 1 month, how much interest has that earned? You'll see it's very close to $1,051.07. So as time goes on, you can slowly pick away at the principal, but to begin with, you're paying mostly interest and then a little bit towards the principal, towards the initial loan. So now, let's say 10 years have gone by, and we want to know what is the unpaid balance on the loan after 10 years. Now, the way that we find the unpaid balance is essentially we're going to take our equation that we had before, and let me go ahead and just slide back up to that. Here was our equation for an amortization. These two things have to equal out over time, right? But in between, they're not going to be the same. So our unpaid balance is going to be the difference of the two. Remember, the left-hand side that was like the perspective of the bank. So this is how much the bank's investment is worth, and the right-hand side is what we had paid so far. So if we take the left-hand side minus the right-hand side, that will give us how much we owe on our loan at any point in time. So our formula for the unpaid balance is going to look like P times 1 plus R over N raised to the NT, that was our left-hand side, minus the annuity formula, R times 1 plus R over N raised to the NT minus 1, all divided by R over N. And in this case, time is not going to be the length of the loan, time is going to be time elapsed right now. So how much time has passed on this loan? So if we want to find the unpaid balance for our particular loan after 10 years, the unpaid balance is going to be the initial amount of the loan, $125,000, 1 plus our interest rate, 0.095 over 12. Now this time is going to be raised to the 12 times 10 because 10 years have gone by. So there's 20 years remaining on our loan, but 10 years have gone by so far. Minus R, and we solved for R in part 1, so we have 1051.07 times 1 plus 0.095 all over 12 raised to the 12 times 10. Again, it's 10 because 10 years have passed. We're not looking at the entire length of the loan, only the 10 years. And if we multiply this all out and subtract, we get that the unpaid balance comes out to, let's see, $112,000, $759.20. Again, round up. It's better to estimate that you owe a penny more than you do because then you'll pay slightly more, and that's fine. You don't want to underpay though. So at the end of 10 years, even though we've been paying, over $1,000 every month, so 120 months at over $1,000, we've paid basically the original amount of the loan, right? That was $125,000. So 120 months have gone by over 10 years, and we've paid more than $1,000 every month. We've definitely paid out of our pocket $125,000, but we still owe the bank. Right now, our loan is worth $112,759.20 because we've been paying the interest, right? Every month, a little bit of our payment goes towards the principal, but since we owe so much right now, most of our payment is going towards interest. As time goes on, our payments will make more of a dent on the principal, but at the beginning, most of your payment is going towards interest. That's why if you have a loan and you can pay more than the minimum payment, and this is true of like credit card loans, if you have an auto loan or a home loan or a student loan even, if you can pay more than the minimum payment, anything you pay over goes directly towards the principal. So for example, if Stephanie paid $2,000 a month instead of the $1,051, the original, the $1,051, that is what her minimum is, and then anything above that is going to knock down the principal. So the next month, her payment is going to have more of it go towards the principal than towards interest, because you'll be owing less, so you pay less interest. Okay, let's see. So now we have our unpaid balance, almost $113,000. Now, the reason we wanted that is because now it's 10 years later, and we have a better interest rate available. So what we're going to do is we're going to refinance. So that means we're going to essentially take out another loan for a different interest rate, and we're going to take out the loan for the unpaid balance. But we're going to pay that unpaid balance at the new interest rate. Okay? And so we'll be able to pay off the old loan, and then now we'll be paying a new loan at a better interest rate. So now for this new loan, we have P, big R, little n, and little t. Let's see, so we're able to refinance the remaining 20 years. So our time now is 20. Our annual interest rate is 7.5%, so 0.075. And we know that P is our unpaid balance from our previous problem. So $112,000, $759.20. We don't know the payments, the monthly payments, and then little n is going to be 12 because we're making monthly payments. So now we're essentially doing the same thing that we did in problem 1 for this, so step 1 rather, but now we have a different, what's changed is little r has changed, P has changed, and T has changed. So we should expect different monthly payments. They may be higher or they may be lower, but they should definitely be different. So if we set this up, left-hand side we'll have 112759.20 times 1 plus 0.075 over 12 raised to the 12 times 10. And this is going to equal the right-hand side. We have our unknown r, and then we times 1 plus 0.075 over 12 raised to the 12 times 10 minus 1. This is all divided by 0.075 over 12. And let's see, on the left-hand side, we end up with 502998.1598. And on the right-hand side, we get 55.3.73075. Dividing through, we end up with $908.39 are the new monthly payments. Now keep in mind, if you do refinance, you may end up with a higher monthly payment, and that's fine. If you change the length of the loan, then that's usually when your monthly payments could increase. So instead of refinancing for 20 years, what if you refinanced for 15 years? Well, then you're probably going to pay a little bit more every month because you have to pay it off faster, okay? So just keep that in mind. So just because you refinance doesn't mean that the monthly payment will go down. So now that we've looked at the new monthly payment, let's figure out how much she's going to save by refinancing. And the way that you figure out your savings, you have to figure out, what was I going to pay, and then what am I going to pay now? And so what we'll do is we'll take the old payment, so in this case that was like $1,051, and then we have to multiply it by how many payments we had remaining, so the number of remaining payments for that loan. So when you refinance, you can change the length of the loan, right? So the number of remaining payments for the remaining payments for the old loan isn't necessarily the same as the number of remaining payments for the new loan. Just keep that in mind. And so from that, this is what we were going to pay. We're going to subtract our new payment times the number of remaining payments. So these two could be different numbers. Okay, that's the main thing. So let's see, for our example, our old payment was $1,051.07. And when we refinanced after 10 years, and so we refinanced for 20 years, and the original loan was 30 years, so there were 20 years left. So that means that we had 20 years of 12 payments, so 240 payments remaining. Minus, and now our new payment is what we just found, so $908.39. And how many payments do we have remaining? Well, we have 20 years, 12 payments every year, so 20 times 12, or 240. And so we end up with a grand total savings of $34,243.20. That is a chunk of change, right? So refinancing can save you a lot of money. If you pay off the loan even quicker, so in this case we kept the loan still 30 years total for that mortgage. If we had shrunk the length of the loan, so maybe paid it off in 15 years instead of 20, then this number could get a lot bigger. Just keep in mind though, if you're like thinking about this in the future, when you refinance, there are usually fees. So you want to make sure that your savings minus the fees that you have to pay is still going to be worth it. Because usually when you refinance, you have to pay like to get your house appraised, and then the bank has some sort of fee for doing the refinancing, and there's all this stuff. But you can figure out, kind of your basic, how much you're going to be saving in interest by doing this, and then you can start, comparing this to how much you have to pay to actually refinance, and just make sure that you're still, saving money by refinancing and not losing money in the long run. All right. So, kind of a neat example. I hope that this was interesting, and that's all.